This is lesson 5, quadratic equations, on pages 267 through 272 of your textbook. The key concept for this lesson is the zero product property. The zero product property states if A times B equals 0, then A equals 0 or B equals 0. And the example we are given is this quadratic in factored form. If x plus 3 times x minus 7 equals 0, then x plus 3 equals 0, or x minus 7 equals 0. Let's explore what that looks like when we are considering this quadratic graphic. I'm going to give us just a little space to the right. Consider a Cartesian graph. Consider a quadratic. That's a okay quadratic, not quite to the scale. If x plus 3 times x minus 7 equals 0, then x plus 3 equals 0, or x minus 7 equals 0. When we use the zero product property, we solve for each one of these factors. We solve for the x in each one of these factors. So x plus 3 equals 0. Subtract 3 from both sides, x equals negative 3. That means the x-intercept is right here, and that is negative 3, 0. On the other side, I have x minus 7. I add 7 to both sides, x equals 7. That is the second x-interceptor solution. That is 7, 0. The standard form of an equation is in this form: ax squared plus bx plus c. The only condition is a cannot equal 0. If a equals 0, we are no longer dealing with a quadratic, we're dealing with a linear function. For the quadratic in our example, in standard form, it would be x squared minus 4x minus 21. In this same example, the zeros of the function are the x-intercepts, which would be negative 3, 0 and 7, 0. So the zero of a function is the value of x when y equals 0. Or when we are looking at a graph, so I'll write or when we are looking at a graph, the 0 is the x-intercept of a function. And I say the x-intercept, but it could be multiple x-intercepts. In this example, we have 2 x-intercepts. So our key vocabulary and concepts: zero product property, standard form of a quadratic equation, and zero of a function. Let's move on to the examples where we are solving by factoring, by square roots, and by graphing. In example number 1, we're going to solve this quadratic by factoring. The first step is write it in standard form. It's already in standard form, this example, but all your examples will not be in standard form. So make sure that you do write your quadratic in standard form first. Second factor, you can use the method that you are most comfortable with. I'm going to use the box method. I like the box method. However, you can use the procedure that you like best. So for the box method, I write the first term, my A term in the first box, and the last term, my C term in the last box. I multiply those two together. 3x squared times negative 7 equals negative 21x squared. I want the factors of negative 21x squared that sum to b. B is negative 20x. Quite quickly, I can see that negative 21x times positive x are my two factors, because negative 21x times x equals negative 21x squared, and negative 20x plus x equals negative 20x. I will write my factors in the remaining boxes, doesn't matter which. Now I am going to factor cross greatest common factor between 3x squared and negative 21x is going to be 3x. On the bottom, I am going to do the same thing, but factor across. And the greatest common factor between those two is just 1. I'm going to factor down. So the greatest common factor between 3x squared and x is going to be x. And again, I'm going to factor down on my second row. And that's going to give me the greatest common factor between negative 21x and negative 7 is negative 7. Those are my factors. And I always like to check my signs. My signs are good. I am going to write my factors. Oops. So my factors are 3x plus 1 times 7x minus 7. And those are going to be set to 0. Right. So I've written it in standard form. I've factored. Now I am going to use my zero product property in order to solve for my 2x values. First, my second. My first equation that I'm going to solve for is 3x plus 1 equals 0. My second equation is x minus 7 equals 0. Three x plus 1 equals 0. I'm going to subtract 1 from both sides. That's going to give me 3x equals negative 1. And then I am going to divide by 3. Both sides. X equals negative 1/3. On my second equation, I'm going to add 7 to both sides. That's going to give me x equals 7. And I've solved for x. I always want to check my answers. That's one of the beautiful parts of this type of algebra. We can check our answer. So you can check it in standard form, or you can check it in this altered form where all the x's are on one side and equal to the constant. So in the first one, I am going to plug in negative 1/3 for x. And instead of writing equals, then I'll put a little question mark over it because I'm not sure that it equals 7. I think it does. When I square it, I get 1 over 9. And then when I multiply both of these out, I'm going to get 3 over 9 minus plus minus negative. So plus 20 over 3. Still not sure if that equals 7, but I do know that 1 over 3 is a simplified form of 3 over 9. So 3 over 9 simplifies to 1 over 3. 1 over 3 plus 20 over 3 equals 21 over 3. And that definitely does equal 7. So yes, x equals negative 1/3 is one of my solutions. I am going to do the same thing for 7 as a solution. I plug in 7 everywhere there is an x. Still, I put that question mark over the 7. I'm not quite sure. It equals it. Think so, but not quite sure. Let me square 7. That gives me 49. Then I'm going to multiply out those two terms. That gives me 147 minus 140. And that does equal 7. So yes, x equals 7 is my second factor, my second solution. Let's move on to solving by square roots. Solving by square roots is really helpful and really easy when b equals 0. So put that in green. When b equals 0, that's when we really want to use this. It's not the only time, but it's really helpful. And it's a really quick way to solve for quadratics when the middle term is missing. So we want to rewrite our equation in the form of ax squared equals c. So again, for solving by factoring, we write it in standard form. For solving by square roots, when b is equal to 0, we write the equation in the form ax squared equals c. So I have 6x squared equals 486. I'm going to isolate the x squared term by dividing both sides by 6. And when I simplify that, I get x squared is equal to 81 because 486 divided by 6 is equal to 81. Next, I take the square root, both sides, and that's going to give me x is equal to positive or negative 9. The reason why you get two answers, positive 9 and negative 9, is because 9 times 9 is 81. So is negative 9 times negative 9. So you get two answers. X is equal to plus or minus negative 9. You can use square roots to solve these very important equations you will see all the time in physics. They model projectile motion. So anything is being dropped or thrown. This is the type of equation you will see. that is going to model the behavior of the object that's being dropped. So in this question, the function y equals negative 16x squared plus 270 models the height y in feet of a heavy object x seconds after it is dropped from the top of a building that is 270 feet tall. How long does it take the object to hit the ground? Let's go ahead and solve this using square roots. So in this problem, I'm going to substitute 0 for y. The reason why I'm doing that is because I am looking for my zeros, my x-intercepts. So that is, they occur when y equals 0. I'm going to isolate x squared. First, by subtracting 270 from both sides. Then next, by dividing both sides by negative 16. Negative 270 divided by negative 16 is 16.875. Then I take the square root of both sides. So here, I just like to switch my variables so it's on the left side. You do not have to. It is the symmetric property of equality. They are equal to the same thing. Doesn't matter which side of the equation sign they're on. But here I'm going to take the square root of both sides. Now I'm going to get a number that's irrational because 16.875 is not a perfect square. So I'm going to get a number that is irrational. Lots of decimal places. I'm only going to write about 3 of them. Okay. So, and then I'm going to use that. That is my answer. How long does it take the object to hit the ground? It takes 4.1 seconds. So I use that, and then I even round it off a little bit more to probably about 1 decimal place. 1 decimal place seems 1, maybe 2 decimal places seem good. Okay. It takes 4.1 seconds for the object to hit the ground. For the quick check, take a few minutes and try these. Pause the video. Try your hand at solving. Solve the first 3 by factoring. Solve the next 3, the last 3, by square roots. I'm going to write the answers so you can check your work. Hopefully all of your answers were correct. If they were not, go back and check your work. Make sure that you are using the correct properties of equality, subtracting, and adding in the correct order. Let's go to our third method of solving by graphing. When we solve quadratics by graphics, sometimes we're using our hand-drawn graphs. but most times we are using the calculator. And the reason why is graphing systems of nonlinear equations can prove to be a little bit more challenging than graphing systems of linear equations. These equations tend to have irrational intersections, which makes it sometimes a little bit harder to do by hand. So we tend to use our calculator. For example, you will need your calculator. So take a few seconds, pause the video if needed, go grab your calculator. Now that you have your calculator, let's start on example number 4, solving by graphing. And again, we are using our calculator for this graphing. A carpenter wants to cut a piece of plywood in the shape of a right triangle as shown. He wants the hypotenuse of the triangle to be 6 feet long. About how long should the perpendicular sides be? So our hint, right triangle, hypotenuse, that means we are probably going to be using Pythagorean's theorem. It's such a powerful equation, particularly when we are dealing with right triangles and we are attempting to solve for sides. Pythagorean's theorem is a squared plus b squared equals c squared, where c is the hypotenuse. In our problem, it doesn't matter which leg, which perpendicular side is A or B. The only thing is the hypotenuse must always be C. So let's let our shorter side be A and our longer side be B. So the shorter side is going to be A or X. The longer side is going to be X plus 1. When we write this as a quadratic, we are going to write our equation in the form of Pythagorean's theorem. A squared plus b squared equals c squared. You will notice in your notes that you can switch wherever c is. You can have c squared equals a squared plus b squared, or you can have a squared plus b squared equals c squared. That is, again, the symmetric property. So I'm going to write a squared, which is x, plus b squared, which is x plus 1, squared equals c squared, which is 6 squared. Recall, when we have binomials that are being multiplied, we can't just square the terms that are inside. We must square the entire binomial. And in order to do that, we use FOIL. So when I am writing out my binomial, I have x plus 1 times x plus 1. Expand, that's going to give me x squared plus x plus x plus 1. And don't forget the x squared from the shorter leg. And all of that equals my hypotenuse. Combine like terms, I get 2x squared plus 2x plus 1 equals 36. I'm attempting to solve for intercepts, so I am going to subtract 36 from both sides so that I can set my quadratic equal to 0. That gives me 2x squared plus 2x minus 35 equals 0. This is the quadratic I'm going to use in my graphing calculator. Pull out your graphing calculator. I'm going to switch my screen. We're going to graph this together. I go to my Y menu. I am going to enter my equation, 2x squared plus 2x minus 35. I always like to use my Zoom 6 to give my standard window, just in case I've been graphing some plots before. I don't have to see my vertex on my graph to solve this one, but I would like to see my vertex. So I'm going to adjust my window. I'm going to increase my Y min because it needs to get way more negative. Let's try 50. Not just gave it a go because the y-intercept is negative 35. So let's graph and see what that looks like. That looks good. You don't have to have your vertex, but I'd like to see my full parabola, especially with that vertex is such an important point. And oftentimes I may be asked about that point. So I am going to solve for my zeros. I don't need to solve for the negative zero. The reason is because we are talking about length. Length is not ever going to be negative. So I really want just the positive. So second calc, I'm looking for a zero, and I'm looking for the right zero. I choose my left bound by moving my cursor, and then I choose my right bound. Does it really matter where your interval is as long as it includes the zero you are looking to analyze? And if it includes the zero, the function goes from positive to negative or negative to positive, meaning it has to cross the x-axis. So now that I've chosen my left and my right intervals, tell the calculator to guess. X is 0. My x or my 0 is 3.713. So when I go back to my problem, x is equal to 3.713. And I use my graphing calculator to find that solution. It's the positive solution, no need for the negative. So if x is the shorter length and x plus 1 is the longer length, then the sides of my triangle are going to be 3.7 and 3.7 plus 1, so 4.7. And rounding off to 1 decimal place, maybe 2 is enough. For the quick check, you can either solve this problem algebraically or with your calculator. We'll do both. Let's give some space to work. The question says, a smoke jumper is a firefighter who parachutes into areas near forest fires. Smoke jumpers are in free fall from the time they jump out of a plane until they open their parachutes. The function y equals negative 16 t squared plus 1400 models a jumper's height y in feet at t seconds for a jump from 1,400 feet. Using square roots, find the time during which the jumper is in free fall if the parachute opens at 1,000 feet. We are given the equation that we are going to analyze. Y equals negative 16 t squared plus 1400. We want to find what is happening when the height, or y, is 1,000. In your calculator, you would have two functions. Y1 would be negative 16x squared plus 1400. Y2 equals 1,000. If we were doing this algebraically, we have y equals -16t squared. And notice, if you're putting it in your calculator, you must use x. If you're doing it by hand, you can use t. So this is my equation. But instead of solving for y, I'm going to solve for 1,000 because that's the y that I want. I left off the negative on the first one, so I need to go back and put that in. It is negative. Okay. Solving by square roots, I will subtract 1,400 from both sides. That gives me -400 is equal to -16t squared. I will divide both sides by -16. In this case, I am trying to isolate t squared. So -400 divided by -16 equals 25. As mentioned, I like my variables on the left side, so I will use my symmetric property just to switch them. Take the square root of both sides. I will get positive and -5. Time, just like distance, cannot be negative. So t equals 5 seconds. That is the time the jumper is in free fall if the parachute opens at 1,000 feet. That is solving our equation algebraically. Let's solve it graphically using our graphing calculator. I will switch my screen to my calculator. Going to my Y menu, I'll clear this one out and put in my new equation. My new equation is -16x squared plus 1,400. My second equation is 1,000. That's y equals 1,000. And we are doing a system of nonlinear equations, one linear, one quadratic. So I like to do zoom 6 just to give me a standard window, and that is nowhere near what I want it to be. But I know the y functions that I'm plotting. One has a y-intercept of 1,400. The other is a horizontal line at 1,000. So in my window, I'm going to make my y max 2,000. Well, it could be 1,500 to include both, but 2,000 is good. And I'll make this 100, just so I won't have all those tick marks. Let's graph it and see. Oh, that's really nice. What I need to find is the intersection. So I'm going to do second calc. Number 5 is intersect. I'm choosing my first line. I like to get a little bit closer to my intersection. I don't want them to give me the -1. First curve, second curve, and guess. And my intersection is the same thing that I got algebraically, x equals 5. So that is solving graphically. You can solve algebraically or graphically. Continuing with the problem. The second part says, now that you've solved using square roots, solve by factoring. And which one do you like? Explain. So giving ourselves some room to work on this problem. This is our equation. Y is equal to negative 16 t squared plus 1400. But remember, we are looking for our answers when y is 1000. So we are going to set y equal to 1000. Y is equal to 1000. Let's make sure that our equation is in standard form. So we will have 0 equals negative 16 t squared, subtracting 1000 from both sides, and that gives us plus 400. Because we're factoring, we have to use our factoring tools. I am going to factor out a negative 1, which gives us positive 16 t squared minus 400. Inside, this gives me two terms, which means I can use difference of squares. So negative 4t, square root of 16t squared is 4t. And then I have the square root of 400, which is 20. So I have 4t minus 20 and 4t plus 20. I used difference of squares. Then I solve for t. I'm going to solve for t using this equation, because this one is going to give me negative 5. We don't want negative 5. So when I solve for this equation, I get 4t minus 20 equals 0. 4t equals 20. And t equals 5. And that's the same as when I solved my square roots. I solved my graphic. And this is now solving my factoring. And the question asks, which method do you prefer, and explain. And there's really no right answer. My preferred method would be graphing, but I also like solving by square roots. It's a little bit easier than solving by factoring. But you may prefer factoring. Again, there is no right answer to this question. When we move on to number 4, use your graphing calculator to solve each equation. These could be solved using completing the square, but it's probably easier to solve these by using your graphing calculator. Take some time, get used to entering in equations, making sure that you can change your window, and solving equations, which means finding the x-intercepts, zeros as they're called in your calculator. Pause the video and see if you can find the answer to all 3 of these. I am going to type the answers. Hopefully you got all of those correct. If not, make sure you are entering the correct equation in. Make sure you're entering it in standard form, and make sure you are setting an appropriate interval in order to find both of your intercepts. And remember, you cannot find both at the same time. You have to do them one at a time. This ends lesson 5.5.